So I'm here at the Argentine Institute of Radio Astronomy, about just outside of La Plata, about an hour south of Buenos Aires, with Ezequiel Zubieta, who is a doctoral student who specializes in the study of pulsars. And you've been making observations here at this observatory using the two 30-meter telescopes, currently part of the PuMA program, as we have been talking about, the pulsar monitoring program in Argentina. And you're studying 10 pulsars, but you are most interested, if I'm not incorrect, you're interested in the not the magnetic glitches, but the glitches in the pulsar measurements. And tell us what a what how do you define a glitch?
Well, as you say, we are observing pulsars here with the radio telescopes, and pulsars usually have a really stable rotation because they have a really huge moment of inertia. However, sometimes some pulsars present glitches, which are a sudden increase in the rotational frequency of the pulsar. This means that at some point the pulsar starts to spin faster and then goes back to the state that it was before. These increases in the rotational frequency are probably related to the behavior of matter inside neutron stars. However, we don't really understand how the matter behaves inside neutron stars. Therefore, glitches are our way to have hints or more intuition or what is going on with the matter inside the neutron stars.
And the matter inside the neutron star, you tell me most likely is what is known as a superfluid. Can you tell me how do you define a superfluid?
Well, a superfluid is a state of matter that we don't really understand yet. This means that it is not solid, not liquid, or not gas. The matter inside the neutron stars is so dense and so compressed that it is in this state of matter that we call superfluid.
A superfluid.
Yeah.
And so this is not just esoteric. In other words, this does potentially impact what we understand about the cosmos in terms of theory, but it also could have long-term application to applied science or applied physics here on Earth. So in other words, maybe electronics, maybe medicine, if we can understand this superfluid state of matter and somehow replicate it in the laboratory. Is that correct?
Exactly. We yet don't really understand how this matter behaves, but once we can have more insight on how this kind of matter inside a neutron star behaves, we could start to use it here once we can.
On Earth, you mean?
On Earth, once we can learn how to build it, and there are probably many applications that we still don't really we are not capable of imagining it really yet, because we don't understand how it works, but we can also have insights of how this matter behaves and what is the relation of, I don't know, for example, the pressure of this matter with the temperature of this kind of matter, and that will give us information on different physical states of matter, and this way we can understand better about how matter works in different places.
And what interests you most about pulsars? Why did you get involved with this?
Well, I think pulsars are fascinating objects. On one side because they're the stars, but also they have really fast rotations. There are pulsars that rotate 300 times a second, for example, and this is really interesting because we can use them as a clock that will help to detect gravitational waves. So this is one of the most interesting things about pulsars. But on the other side, I'm really interested in pulsar because, and once as I say, we don't know how the matter behaves inside the neutron stars, but also they have a stable rotation, but we know their magnetic field is changing all the time, so they are objects that we don't really understand how they work.
So by studying them, we are better understanding pure physics, not just the cosmos.
Exactly. We hope to understand the way that it works, so we will understand more about magnetic fields in these kind of extreme objects, about the behavior of really condensed matter like it is inside neutron stars. We will also detect gravitational waves of different uh, wavelengths that will help to understand a binary system of massive black hole, and we can understand many things through studying pulsars.
So thank you so much, Ezequiel, for taking the time today to talk to us, and we look forward to hearing more from your work.
Thank you for your interest in